Hello, this is Mrs. Simons looking at 2.8 and 2.9, both solving and graphing inequalities. Recently, we've been solving multi-step equations with variables on both sides. We're actually going to take a step back in time and look at those easy equations that we started with so long ago. They were equations, so they looked something like this. Today we are going to be looking at inequalities, which means that instead of an equal sign, we are going to have an inequality symbol. So if I give you a problem like this, you're going to solve it just as we used to, where we would isolate the variable and undo the operation that's occurring to that variable. So we're going to undo adding 3 with subtracting 3. This is going to seem really easy compared to where we've been going. But when we do bring down, it's not an equal sign, it is an inequality symbol, so we want to make sure that we include that. And of course, negative 5 minus 3 more, or negative 5 plus negative 3 is going to be negative 8. Now typically when we've been solving equations, there was just the one solution. We looked at some unique situations where there were no solutions, or every number was a solution, but typically they had one. In inequalities, they do have more than one solution, but it's not all numbers. When we take a look at this answer right here, this answer indicates that x could equal negative 8. That's what this part of the or equal to symbol is. Or x could be greater than negative 8. So this symbol right here is telling us what numbers x can be. On a number line, what that would look like is that we would need to indicate that negative 8 can be the solution. And so we could put a solid dot over negative 8, indicating that negative 8 is a possible solution. And then we would draw an arrow to the right, indicating that all of the values that are larger than our negative 8 are solutions. So that would include numbers like negative 7, but not negative 9. Let's take a look at another problem. Let's say that we have a negative 8 is greater than, let's do an x minus 7. And so we would go about solving this as we have been, drawing that vertical line now through the inequality symbol, circling our variable and asking how we can undo subtracting 7. Of course, adding a 7 will eliminate that minus 7. We do that on both sides, and so that's going to cancel out, and we're going to end up with x isolated. We're going to bring down the inequality symbol, and negative 8 plus 7 is negative 1. Now this problem, because the variable is on the right side of my equation, it's a little more difficult to read out loud. We would read it either as negative 1 is greater than x. That means that negative 1 is bigger than all of our solutions. Perhaps easier would be if we were to go and flip-flop the variable and the negative 1, making sure that the inequality stays true. So if the alligator was eating the negative 1, the alligator still needs to eat the negative 1. And this is a lot easier to read, indicating that x, all of our numbers for x, are less than negative 1. On a number line, what that looks like is that if we have our negative 1, and then if we go up bigger, that would be 0, and smaller would be negative 2. Since negative 1 cannot be a solution, and the reason I know it's not a solution is that there is no or equal to symbol underneath. If there had been an or equal to underneath here like this, I'm going to get rid of that because that wasn't there, but if it had been there, we would have a solid dot. Since it is not there, then negative 1 is not a solution. So we put an open circle indicating that we're not filling it in. It does not include negative 1, but it is all the values that are less than negative 1. And so I can then point this direction, showing me that it is all of the numbers that are smaller than negative 1, but not including negative 1, and that's what that open circle means. All right, so a quick recap on our inequality symbols. We have a less than symbol that looks like this. we have a greater than symbol that looks like this. It is like reading a book from left to right. So if the smaller number is left on the left and the bigger number is on the right, we're reading it as that smaller number on the left is less than the bigger number on the right. And vice versa for greater than. Those, when graphed, are going to include an open circle because they do not include the value that that open circle is on that number line. Less than or equal to is going to be that same less than symbol and then half of an equal to sign. You can almost even see where that equal sign is. There's an equal sign, but then that additional piece right there is telling it's less than or equal to. And then, of course, we have greater than or equal to. And these two, when we graph them, are going to be a closed dot because we are including the numbers that that dot is on the number line. So it's or equal to. That or can be a little bit confusing for some students, but it is indicating that it can be that exact number that's on that number line or any number that's either less than or greater than, depending on the problem. On your homework, you may be given a graph and asked to write an inequality. And again, these are 4 separate problems that I have here. So when looking at this top problem right here, when we look at the dot being above 13, what we should know is that we are going to be, that we are going to be comparing x to 13. We always put the variable listed first because it is a closed circle. I know it's or equal to, it can include 13. And the arrow to the left indicates any number that is smaller than. That's that less than symbol. So if we were to read that as x is less than or equal to 13, we're showing on the number line that it can be 13 or any value smaller. By the way, the direction of that arrow is very important, but how far that arrow points to the left, it does not matter where that actual arrow ends up. It's just pointing in the direction where all of the answers are. So remember, that arrow goes on and on forever to infinity. Any number less than 13 will be a solution. If we go to the next problem, I see my -7, so I'm going to be comparing x to -7 because it's an open circle. It does not include -7. It is only the values that are greater than -7. And so that would be our answer. Reversely, if they just give us an inequality or if we've solved an inequality and we get that answer of x is greater than 3, if we're asked to graph that solution, we create a number line, putting the number that we're dealing with in the center. I usually go up 1 and down 1 just to remind people we get bigger when we go to the right and get smaller when we go to the left. And then I would double check if this is going to be an open or closed circle. It looks like it is going to be an open circle, so it is not including 3, but it is all the values that are greater than 3. And so those values would be to the right. If we take a look at the last problem there, I do highly recommend that if the variable is not listed first, is that you rewrite it with the variable listed first, and then make sure if the alligator was eating one of the values that it's still eating that value. And these two are equivalent. -5 being greater than or equal to all of our solutions is the same as saying all of our solutions are less than or equal to -5. And find that students make fewer mistakes when that variable is listed first. -5 is the number we're dealing with, and so numbers that are bigger than that would be going towards -4. Smaller than that would be -6. Because it is an or equal to, we are talking about including -5 as a possible solution, but so are all of the values that are less than. I have had students make a connection that when they see an inequality with the variable listed first, that it actually is an arrow pointing in the direction that our arrow is pointing. So notice when the variable is listed first, that's essential, that inequality is actually an arrow pointing the direction that it will on the graph. And again, that's yet another reason why I think it's so important for us to list the variable first. Sometimes we're asked to translate a situation into an inequality. Like this example, this class can have no more than 30 students. We would have to be asked to write an inequality about it. we would say that x is the number of students that could be in the class, and if there can be no more than 30, we know we're comparing it to the number 30. No more is kind of tricky because I think usually when students see more, they think greater, but that no actually negates that. And so we're actually talking about something being no more than 30 is really saying it can be 30 or anything less. So no more is really a less than or equal to. And at least is a greater than or equal to, because if you're saying something is at least that, it's that much or more. So be really careful about no more, which is actually going to be less than or equal to, or no less is actually going to be greater than or equal to. At most is going to be less than or equal to, and at least is going to be greater than or equal to. And that kind of goes against what seems logical when we're talking about more than being with a less than symbol, and less being with a greater than symbol, and so on. All right, let's wrap up with translating words into an inequality that we can solve and graph. It kind of combines everything that we've looked at. So when I see the word sum, I know we're talking about adding, and it looks like the values that we're adding are x and negative 3. So x plus negative 3. I see is no more than. So that is usually an equal sign. When it's followed by no more than, we know we're talking about an inequality symbol. And so is no more than means that it can't be, that negates that more than we're talking about. It could equal 15 or it would have to be less. It can be no more than 15. So 15 is the most it can be, or that value, or it can be less than that 15. So that's the first part, is just getting this piece right here where we translate. Now the second piece is going to be solving it. And so when we go to solve it, much like we have with equations, I know that adding a negative 3 is the same as subtracting a 3. So I'm going to undo that subtracting a 3 with adding a 3. Otherwise, you know that a positive and a negative cancel out, and we get that x is less than or equal to 18. And then the third and final piece is then graphing those solutions on a number line. My number line needs to include 18. I know numbers to the right are bigger, so there's 19, and to the left are smaller. When I take a look at this inequality symbol, because of the or equal to symbol there, I know that I'm going to be dealing with a closed circle. 18 is a possible solution. If I were to plug 18 in right here, 18 would be equal to 18. But so would any number less than 18 be less than or equal to 18. And so I'm going to continue and draw my arrow to the left, indicating that all the numbers that are smaller than 18 are solutions. So there's a whole range of solutions. It's not every single number out there, but it is a lot of numbers. It's 18 and anything smaller than 18. Keeping in mind there are a lot of fractions and decimals in between those intervals. So 18 is a solution, so 17.9, so 17 and 2/3. Any number that is to the left of 18 on that number line will be a solution. All right, I think that's it for now. I hope that this was a success. Please let me know if you've got any questions about this material. Thank you.